Jim, everyone. I'm good to have everybody here once again, and I'm pretty much excited to start lesson 3, right? I hope that you all can see my screen. So today we'll be doing like a deep dive into Solidity fundamentals, right? In the last class, we've talked about blockchain fundamentals and also, Neo kind of like walk us through Kaia 101. And the next thing on the syllabus is to um, take a deep dive into Solidity fundamentals, right? So if you recall, we talked about smart contracts, right? For a bit during the 101 and also like blockchain fundamentals, right? Um, we kind of like talked about how this is used to like encode business logic on the blockchain using a programming language like Solidity, which is like the most popular smart contract programming language, although we have others, right? So today, I'm going to like dive straight into Solidity fundamentals with the head start in understanding Remix, right? Basically, Remix is like a web browser-based or an online end-to-end smart contract development framework or tool that helps you to like write smart contracts, test smart contracts, compile, and also deploy smart contracts. And even at the end of the day, interact with the smart contracts, right? So without further ado, let's jump, right in, right? So like I mentioned, Remix is first a web browser-based end-to-end tool for like smart contract development. And what that means is that it doesn't require you to download any sort of like dependencies or any sort of like software before you access it. You with just your browser, you can click on the link and get to access Remix. So for today, I think we're going to be doing quite a number of things exploring Remix for the sake of those who don't know what Remix is. So it kind of like helps us do smart contract development fast, right? It has quite a number of like rich plugins that you can plug and play into Remix and start developing your smart contracts, right? And mind you, I mentioned that your smart contract is a piece of code on the blockchain, and that means that you want to, as an EVM developer or one that will be certified via this bootcamp, what you want to do is you want to help protocols or you want to help businesses bring their logic on chain, right? By building various use cases. And so the first thing we want to do is to head over to Remix. And to do that, you're just going to type remix.ethereum.org, right? Like this, remix.ethereum.org. And it takes you to this web page, right? Just to confirm, how many of us are currently on our laptops? Because this is going to be like a code along section, and I want everyone to follow along, right? Yeah, GM, awesome. I think Jamu GM. I just want to confirm how many of us are currently on our laptops so we can follow along, while we are discussing some of these, fundamentals, such that it kind of like sticks, right? Um, awesome, awesome. Okay, Israel, thank you. So you can basically just head over to remix.ethereum.org and we just get started, right? For the most part, when you click on remix.ethereum.org, it brings you to, this page where you get to see different panels. So for Remix acts as like 4 panels, right? Those icon panel, as you can see, you have the file explorer, the search files, Solidity compiler. Then you have the sidebar panel, which basically houses your contracts and all of your workspaces. Um, your workspace is basically where you get to like write your smart contract. Then we have the main panel. As you can see, this is the main panel over here. This is where like your code will be displayed when you are writing your contract or when you're writing your script file or your test file. And then the last panel is the terminal, which is this part. It kind of like shows all of your transaction requests, when you make transactions or when you call a function, it shows all of that over here, right? So like I mentioned, Remix has 4 panels: the icon panel, the sidebar panel, the main panel, and also the terminal. So it's pretty much important that you understand that. So let's quickly take a look at the icon panel, because quite a number of things we'll be doing will be revolving around yeah, the icon panel, right? In this case, the file explorer. So when you click on the file explorer, you're expected to see um, a basic template. Now, what do I mean? I have created a separate workspace called Build on Kaia 2025. You can click on this icon to create a template or to basically clone a repository over here. So I created a workspace. You can also do the same by just create using templates, and you basically just click on create, right? And give it a new name. So you can say BOK, let's say Bootcamp 2025, right? So I'm just going to click OK. So as you can see, this kind of like bootstraps um, a project folder for us that contains our contract, our script, and also our test files, right? And so this is a simple, basic workspace that houses your smart contract. Okay, so having said that, we have now that we have the contracts and also the script folder and also the test folder, let's understand each of these folder one after the other. So your contract folder is where all of your contract file or your Solidity file will be stored. Just like every other programming language, right? Um, Take for instance JavaScript, TypeScript, they have their own extension, right? When you're writing in JavaScript file, it has an extension of .js. In this case, you can say index.js or main.js, right? So for JavaScript, it's basically .sol, right? When you want to write your smart contract or your Solidity file, you click on this folder and create new file and basically say something like Um, somebody should give me a name. So let's do basic, right? Basic.sol. So this is us creating our Solidity file, right? Yeah. So to recap, to create your Solidity file, especially while using Remix, you go to the contract folder and under the File Explorer tab or icon panel, and you create basic.sol. Now, this gives you like an empty file where you can start writing your Solidity code. Right? So, but for now, we'll not be doing that. Right now, let's go to the next folder, which is your script folder. Your script folder is a folder that contains all of your deployments scripts. When I say deployment scripts, it means that you are writing reusable codes to deploy your smart contracts, and you can use them or you can write your scripts using various libraries. Take for instance itas.js. Take for instance Vim. I think we're still going to talk about quite a number of these. For as many who don't know what itas.js is or Vim is, I think later on in this bootcamp, we'll touch a bit on that. Right. But all in all, a script folder is basically a folder that houses all of your code pieces for deploying your smart contracts using various libraries, right? Either itas.js or Vim, right? And also we have our test file. Now, when it comes to test folder, right, this is where you write all of your test cases for your smart contracts. Now, in the world of smart contracts, writing tests is really, really important because you want to be able to catch all of the bugs or all of the errors that might exist in your code, right? Because, once a code is deployed on the blockchain, it's immutable. Or once a smart contract is deployed on the blockchain, it's immutable. And imagine if you wrote a contract that has various bugs and can be, attacked by bad actors, and the funds are siphoned away. This will tell a lot on your protocol. One of the ways to like avoid this is by writing integration tests or like unit tests. So your test folder sort of like help you house all of your test files. And so depending on the framework that you're using, right, you can either write your test file in JavaScript or like in Solidity. So we'll still talk about quite a number of these frameworks, whether Hard Hat or Foundry, in like one of like the later lessons in the bootcamp. But for the most part, this is what your workspace looks like, right? For the most part, or for like a basic workspace. You have your contract, you have your scripts, and you have your tests. Now, moving forward, you also have the search. You can search for different, files, right? Basic .sol. You can basically just perform search operations over here, right? And you're good to go. Also, yeah, your Solidity compiler is where you compile your smart contracts. Now, a compiler basically helps us compile, or basically helps us translate our high-level language, which is Solidity, to bytecode, because the EVM understands bytecode. So what compilers helps us do is to compile the high-level language, which is Solidity, to um, to bytecode, which runs on the EVM, right? And so this is where you get to like compile your smart contract. Even if you are using like other type of frameworks other than Remix, take for instance, Adapt or Foundry, you still have to compile your smart contract. So the way it works is once you write your smart contract, once you are done, you want to compile your smart contract, right? So that's the step. You write your smart contract. The next thing is to compile your smart contract, right? Just to display how that works, let's take a look at a boilerplate example provided when we were trying to bootstrap our workspace, right? Let's just click on storage.so. The storage.so smart contract, quite a number of things here might be strange, but we'll get to see how all of these things work when we go further in this session, right? What this contract does is that it stores and retrieves value, right? It takes in a number as a state variable, or he has a number state variable, which is a state variable. Then he has two functions that store variable and the other function that retrieves the variable. As simple as that, right? Now, when I go to the compiler and when I click on, compile storage, as you can see, it shows that it has provided the ABI and the bytecode. So I mentioned that the compiler helps us translate our high-level language Solidity into bytecode, which the EVM understands. So this is what is being run on the EVM, right? So for most of the things I'll be doing here, we'll be using Remix for most of the things we'll be doing here. So in order for us not to keep clicking on this button, compile all the time, you can check this box, auto compile. And so whenever you do Control S on your smart contract, when you've written it, it automatically compiles by itself, right? And so that's that about the Solidity compiler tab. We also have the deploy and run transactions. And so this provides us with all what we need to deploy our transaction, or sorry, our contracts, and also interact with them. As you can see, we have the environment field. The environment field is where do you want the smart contracts to be executed? Is it on Remix VM, or do you want to deploy to the blockchain, whether testnet or mainnet? And so this field kind of like provides us all of those functionalities. Now, in the case where we want to deploy to Kaia testnet, which is Kairos, we can click on injected provider, right? So the injected provider sort of like checks for MetaMask, right? And it loads up MetaMask in this environment. Now, when that happens, our account here will be populated with our account on MetaMask, right? So that's what the deploy and run transaction tab does. Now, in this case, for the most part, we'll be doing a lot of deploying to Kairos testnet. If you recall, I mentioned that Kairos testnet or Kaia Kairos testnet is like the simulation of the mainnet, which is basically just used for development purposes, right? To test all of like your smart contract and see how it works in simulation to like the mainnet, right? Pretty much it. I wouldn't want to demo this right now, but let's move on. We also have the debugger icon field and also the GitHub icon field. But for the most part, I think the ones we'll be using frequently is the file explorer, the Solidity compiler, deploy and run transaction tab. Then in some cases, we might want to install some plugins that adds additional functionalities to our remix. Now, what we can do is to just search for such plugins here, right? So in this case, we might want to activate Kaia plugin. So Kaia has a plugin of its own on Remix that helps you to deploy and execute transactions, or also interacts with smart contracts. Now, what this does majorly is that it provides you access to be able to connect your Kaia wallet, right? Instead of like your MetaMask in this case. And so once we activate this, you'll see the Kaia logo over here. And once you click on it, as you can see, there's the environment. It has injected provider Kaia wallet, and it also has injected provider MetaMask. Pretty much it. So you can use the Kaia plugin over here to basically just deploy and run your transactions, either using MetaMask or using Kaia wallets, right? I hope that makes sense. Pretty much it. I think that's like running over what Remix is, right? Just to recap, right? Remix is a web browser-based end-to-end smart contract development tool, right? Meaning that you don't need any kind of like setup. You basically just get to start doing stuff, right? Just by accessing remix.ethereum.org in this case. And we talked about how that you can, it has 4 panels, the icon panel, the sidebar panel, the main panel, and also the terminal, right? Other than that, we looked at, the most important icon panel that we'll be using frequently, which is the file explorer, the Solidity compiler, and the deploy and run transaction tabs. Now, depending on what you want to do or what type of wallet you are using, you can install the Kaia plugin from the plugin manager by just typing Kaia and you get to see it, right? Pretty much. Other than that, I think that's like a quick summary of like Remix. We'll come back to Remix to, demo stuff and, code along as we go. But yeah, let's continue with some of like the slides that we have here, right? Pretty much it. I did talk quite a number of things. How do we get the Kaia testnet plugin, right? You can just, let me go back again and demo that. You can go to Remix, the plugin manager, and type Kaia, right? I think this question, the answer is for Israel. You go over to the plugin manager, you type Kaia, and because I already activated it, now I'm seeing a deactivate button. But in your case, if it's your first time, you're going to see the activate button. So all you have to do is just click on activate, right? Yeah, I think that answers your question. Going back to, yeah, the slides. So yeah, I think quite a number of things that we have been talking about here has been Solidity, because of course this is like the Solidity fundamentals, right? So what is Solidity, right? I just want you to have it at the back of your mind that Solidity is first a programming language, right? It's an high-level programming language for creating smart contracts on EVM-based blockchains, right? When we say EVM-based blockchain, we mean blockchains like Kaia, Ethereum, and whatnot. Any type of blockchain that is EVM based, right? Solidity is the most popularly used programming language for writing smart contracts. So with Solidity, it means that you can create contracts on chain. You can create contracts that helps you build decentralized application, and also to like issuing your own cryptocurrencies, right? I think we're still going to do like a deep dive into cryptocurrencies, right? But in layman terms, Solidity is a high-level programming language for creating smart contracts on EVM-based blockchain, right? So why should you learn Solidity for Kaia, right? Like Neo mentioned in the previous Kaia 101 session, for as many that were there, Neo mentioned how that Kaia is EVM compatible, meaning that all of the tools, all of the development framework, all of the libraries that are available on Ethereum also works on Kaia. And so that would mean that Solidity can also be used on Kaia. So this is why you need to learn Solidity for Kaia. If you're looking to build decentralized application, if you're looking to create products on chain, if you're looking to build or bring business logic on chain, also like issuing your own cryptocurrencies, learning Solidity is like the go-to programming language for you to, execute that, especially when you're trying to build Web3 applications, right? Moving on. So now let's talk about Solidity, right? Just like every other programming language, breaking it down. Now we are going into like the technical specifications, right? Other than just, oh, what is Solidity, or like it's a programming language. Now let's look at the technical specification as a programming language. The first thing is Solidity is a statically typed programming language. Now, what does that mean? It means that you have to be specific about the type of the data that you're working with. In this case, it means that for every variable that you're declaring, you have to specify what type it's that variable. So if you're working with integers, you have to specify that this is an integer. If you're working with strings, you have to specify that this is a string. I think we're still going to like see how this is declared and also initialized when we go into like the code along section. But in layman terms, when we say statically typed, it means that you have to exclusively state what type of variable or data you're working with in this case, right? And at the top of every Solidity file, you will see SPDX's license line and also a pragma line. Okay, so when we say SPDX license line, what do we mean? Now, most smart contracts, or like most smart contracts, we advocate that they are open source, right? Because we tend to want to foster transparency and trust amidst the whole ecosystem. Because when you open source your smart contract, it kind of like build more trust, and also it's kind of like transparent, right? But while you're doing this, while you're open sourcing your smart contract, you might also have to deal with legal issues around copyrights, right? When we talk about copyright, meaning like who has the code, or what you can do to the code, whether you can copy them or you can, use them as is. Now, what Solidity does to like sort of like curb this in a way is to provide an SPDSS license line. And so this can be either MIT, unlicensed, or whatever, right? I think it's pretty much important to take a look at the SPDX license identifier documentation to see all of the various license identifier that you can add to your Solidity code, right? And what they actually mean. So if you had MIT, it will mean that, oh, people can actually use, or people can actually copy your code. If you use unlicensed, this is what it means, and this is what it doesn't mean. And so when you go over the XPDX license identifier documentation, depending on how you want copyright to be issued for like your contract, I think you are going to provide the license identifier that fits this. Also, when we talk about Pragma Solidity, right? Okay, so Pragma Solidity is a way to tell your Solidity compiler that, oh, you should use so and so compiler version, right? So Pragma Solidity is a way to tell your Solidity code that use so and so version. Reason being that there are some version that might have new fixes and whatnot. And if you are writing your smart contract, basically, and you are using a particular compiler version that doesn't have all of the code or all of the features that has been upgraded, it will mean a lot of breaking changes, right? Because take, for instance, let's say in compiler version 6, it has the ability to whether self-destruct, right? And in compiler version 8, we already removed this ability, right? So that will mean that if you want to write your smart contract to add the self-destruct functionality, you have to use compiler version that starts from 0.6 or 0.6, right? Because if you use compiler version 0.8, your contracts wouldn't execute self-destruct. I hope that makes sense. So Pragma Solidity is a way to tell your Solidity file to run certain smart contract program based on a particular compiler version. And now, so when we say Pragma Solidity, the caret icon 0.8.0, what does this mean? This is you specifying the compiler version you should use or the range, right? So you're saying use any compiler version from 0.8.0 to, but not 0.9.0, right? So you can use compiler version 0.8.1, 0.8.2, and whatnot. And also, there are like various ways to declare Pragma Solidity and adding like the compiler version to it in this case. Moving forward, also part of like the technical specifications of Solidity is that you can think of or like Solidity is built around contracts, right? Quite a number of like the things that you'll be doing is built around contracts, right? And you can think of a contract as a class in like object-oriented programming, right? So a class is something that has various properties and also various methods. Take, for instance, class in JavaScript, you can declare a class of, say, the value of a car, right? You can declare a class of a car that has property of color. Color is white and has the various method of drive or park or reverse, right? So same thing, we can think of contracts as also class in object-oriented programming, where in your smart contract or in your contract, your state variables might be your property and your functions might be your method, right? In this case. So to cap it all, right, a contract can hold data, right? Like the balance of an account. It can contain functions to read or modify the data and basically just encode logic, just like we have in the case of a class in object-oriented programming. You know, I mentioned how that in JavaScript, you can write a class of a car that has a property of color and also has proper or like methods to drive, to reverse, and to park. Now, same thing applies in contracts in Solidity. A contract can hold data, which can be like the properties, and it can also have various methods which can modify the property or can read the properties. Now, in this case, we might have a contract bank, right, that has balance, which is the data, and we can write a function in this case to read the balance and a function to modify the balance like deposits, right? So this is what we mean in this case. And so overall, what we are saying is that first, Solidity is statically typed, meaning you have to specify what type of data that you're working with. And at the top of every Solidity file, it's important you specify two important lines, the SPDX license line and the Pragma line, right? Pretty much it. Then moving forward, now let's go over the various data types in Solidity. right? The various data types in Solidity. And that will bring us to understanding variables and how these variables can be, or what are the various types a variable can be, especially in Solidity. Now, in simple terms, a variable or variables are used to store information that needs to be referenced or manipulated later on in a particular computer program. And so what that means is that a variable per se is used to store information. Like I mentioned in the instance of class, right? Once you write a variable, which can be color, right? A color can be referenced later on when you're trying to get the color. Or let's say we write a contract which is a bank smart contract, and it has a variable of balance, right? So balance can be referenced in the get balance function when you're trying to get balance, or can be manipulated, which is or mutated or updated or changed in another function called deposit, right? Which can basically write to the balance state variable in this case. Now, so this is the simple definition of variable. A variable is used to store information that can be referenced and can be manipulated in a computer program, right? They can hold several values such as numbers, text, or whatever complex types. Now, data types in Solidity can be classified into two. Um, so we'll be going into the various data types that we're working with, especially in Solidity. And so we'll be looking at the primitive data types and also the complex data types, right? Still basically like value types and also reference types, right? So I want you guys to understand this, right? Data types in Solidity are classified into two: value types, which sometimes are also called primitive data types, and also reference types, which oftentimes can also be called the complex data types, right? And pretty much important. So moving forward, what are like the various value types and what are the various reference types? So we'll take a look at them one after the other. So for value types, we have signed integers, unsigned integers, booleans, address, enums, and bytes. Now, these are like the 6 primitive value types or data types that we have. And so let's take a look at them one after the other and what they actually mean in this case, or how do we work with them, right? Yeah. Okay, somebody asked that, is the Kaia plugin necessary? I have deployed to the text nest on Remix without it. Oh yes, I think if you are trying to also like use Kaia wallet, you can use the Kaia plugin. But for sure, it's recommended that you use Kaia plugin because of course it's built for that purpose of you deploying to uh, Kaia Kaia networks, right? Whether mainnet or testnet. I hope that answers your question. Yeah, moving forward. So let's quickly take a look at um, unsigned or signed integers. So this is also understanding like the technical specifications of Solidity, what are the various data types and whatnot. So the way this is going to work is we are going to be looking at each one after the other, and going to Remix to sort of like explain and coming back to the slides and sort of like explain. Um, I hope that is going to like be seamless. Now, what are signed integers, right? Or how do we work with signed integers in Solidity? A signed integer is declared with the int keyword, which is int, right? Is declared with the int keyword. That is the signature, or that is how you sort of like declare integers. Now, integers are used to store either positive or negative values in smart contracts, meaning that you can have -100 or -127 or -1000, depending on like the size or the range of the integer. You can also have positive values, right? So in simple terms, an integer helps you store positive values and negative values in your smart contract. Moving forward, an integer or like an integer that is specified as int is also an alias for int256, right? Which means that, let me quickly break this down. Integers have, or they have various steps ranging from 8, right? So you can have int 8, int 16, int 32, and so on and so forth until 256, right? This is the way Solidity has been programmed, right? Each integers have various steps, and each steps have the range of data that can be stored in each integers. Now let's take a look at how integers are declared. We'll take a look at that, but very quickly, let's complete some of like the features of integers. Now, the highest size of an integer is int256, which is also 32 bytes. If you divide 256 divided by 8, it gives you 32 bytes, right? And the default value of an integer is 0. Just want to mention that every variable or like every data type in Solidity have their default value. For integers, it's 0, right? For other type of data types also, they have their default value. We'll get to that when we are trying to also like explain each of the default value for each data type. Moving forward, it has various variations in steps of it. I think I already mentioned this, how that you can have, int 8, int 16, just like in steps of 8 until int 256, right? Take, for instance, you start with int 8, int 16, int 24. So another thing to mention is, how do we calculate the range of data that can be stored in an integer? Take, for instance, what number can be stored in various steps of integer. Take, for instance, int 8. How many values can be stored in int 8? Or how many numbers can int 16 contain? If it gets to certain threshold, will it throw an error? Or whatnot. So let's take a look at how to calculate this. So because integers store both negative and positive value, that means that we need to calculate the number of negative value it can hold, and also the number of positive value it can hold, right? So for the number of negative value it can hold, if you are dealing with int 8, that will mean minus 2 raised to power 8, right? That's the negative value, to 2 raised to power, for int 8 is going to be minus 2 raised to power 7 to 2 raised to power 7 minus 1, right? So let's quickly take a look at how this works. Let's go to Remix so we can see how this works in practice, right? Let me explain this by, so let's quickly create, okay, I think we've created the contract. And like I mentioned, every of your Solidity file needs to have Pragma Solidity and XPDX file, right? And so in this case, we can just use MIT or license or unlicensed, right? And then moving forward, we can declare Pragma. And then we can declare the version to be, so what we are doing here is we are using the unlicensed license identifier, and also saying that this contract can use Solidity compiler version from 0.80 up to 0.8.9, right? 0.8.9 and not 0.90, right? So this is what we are saying. We can also write like, oh, let it range from greater than or equals to 0.8.0 to less than or equal to 0.9.0. So we can basically specify how we want our compiler version to be, right? But in this case, I'm just going to use this caret sign and basically use that. Now, for every type of like programming language, right, there are keywords, right? So if you want to declare your contract, all you have to do is to use the contract keyword and followed by the name of the contract. In this case, let's call it basic, right? And also your curly braces, right? And so this is how we sort of declare our contracts. The first step is providing your SPDX license identifier and also your compiler version, which is Pragma Solidity. Then the next thing is to declare your contract using the contract keyword, followed by the name of the contract, right? And so let's talk about signed integers, right? We mentioned that signed integers can be used to store positive and negative values. Now, we said that to store signed integers or to declare signed integers, we need to use the keyword int, right? So as you can see, in Remix, it brought out various steps of various range for int from 104 to 102 up to int 256, right? So it starts from int 8, then we have int 16, 24, and so on and so forth, up to int 256, right? Pretty much. So once you declare the name of your, or the type of your variable, the next thing you want to do is to give it a name. So let's give it a name of num, right? And you end the line as such, right? With semicolon, right? But in this case, what we want to do is we don't just want to declare, we also want to initialize it. So let's store this to 120, right? We mentioned that integers can store both positive and a negative value, right? Pretty much it. So we mentioned that integers can store positive and negative values, right? Now, how do we calculate, you know, the numbers of, or how do we calculate the range at which this int 8 can store value, right? And so that will be, we'll say minus 2 raised to power the range minus 1, right? Up to then minus 1 also up to 2 raised to power 8 minus 1 minus 1, right? And so we can replace this with n, which is like the step value in this case. So if we are dealing with int 8, the n here will be 8. If you are dealing with int 16, right, the n here will be 16, and so on and so forth. And so if int here is 256, I'm going to replace this with 256, right? So let's take a look at how this works. All right. Let's say this is int 8, right? If we try to store, value 1 2, let's say 128, right? 129. So this sort of like fails, right? Because it can't store value up to 129, right? Because of the range it can contain. And so if we do the maths over here, right, minus 2 raised to power power 7 equals to 128 in this case, right? That would be minus 128, right? And so it can contain value up to 128, right? And over here, I think this part is for this part. And then for the other parts, which is 2 raised to power 8 minus 1, then minus 1. So this is going to be equals to 127. And so if we try to store value that is greater than 127, it's going to throw an error, right? It says 128 is not implicitly convertible to expected type int 8. Literal is too large to fit in int 8, right? And so what we just demoed is literally the range of numbers that can be stored in a particular integer. Depending on the steps in 8, right? It has a formula of how to calculate the range of what can be stored in it. And that's basically because it stores both positive and negative value, right? We are starting from -2 raised to power n minus 1. N in this case is the step, right? Up to 2 raised to power n minus 1, then minus 1, right? So when we did the maths, right, we said -2 raised to power 8 minus 1 is 7. And if you calculate this, this would be 128, right? And then 2 raised to power 8 minus 1 is that's 2 raised to power 7, which is 128, then minus 1, which gives us 127. So if we try to check this, 129, it can't store value up to 129, but it can store value up to 128, right? It can't store value up to minus 128, or it can store value up to minus 128, right? But it can't store value up to minus 129. It throws an error. So this is kind of logic that applies for integers, signed integers, and their various steps, right? I hope that makes sense in this case. Do we have any questions so far? If you have any question, please don't forget to send them in the chat, right? And just to confirm, how many of us are like coding along? Can you sort of like drop your comments in the comments session or like in the chat so we can, be synced? Okay, moving on. Having said that, let's take a look at the other ones, right? Which are like the primitive data. We just talked about unsigned just talked about signed integers, right? Which are used to store both positive and negative values, right? We said they are declared with int keyword. It has various steps in it has various variations in steps of the 8 from int 8 to int 16. And we also took a look at how to calculate what range each of these steps can store. Take for instance, for int 8, it can store value from -2 raised to power 8 minus 1 to 2 raised to power 8 minus 1 minus 1, right? Pretty much. Moving forward, let's take a look at unsigned integers, right? So what are unsigned integers? Unsigned integers are used to store either 0 or positive values in smart contracts. Unlike signed integers are used to store both positive and negative values. But for unsigned integers, they are used to store either 0 or positive values, right? That's pretty much it, right? Bless me. Also, you can declare your unsigned integers with the uint keyword. In the case of integers, or signed integers, we use the int keyword. In the case of unsigned integers, we used the uint keywords, which is UINT, right? Also, the default value is 0. Also, it has various variations in steps of 8, uint 8, uint 16, uint 24, up to uint 256, right? We have various size, right? Which means that uint 8 is 1 byte, uint 16 is 2 bytes, and up to uint 256, which is like 32 bytes, basically, right? And how do we calculate the range of what value each can store, right? That will mean that we need to go back to Remix. And let's sort of declare unsigned integers, right? Let's say uint 8, let's say sum, right, equals 20, right, and your semicolon. Now, what we are trying to do here is we are using a variation of uint 8, right? Now, we can also use a variation of uint 16, right? A variation of uint 24, right? Up to uint 256. That's what we mentioned, right? Also, we can calculate the number of the range of values that each of these variations can store. And how do we do that? Because uint store value from 0 up from 0 and also positive values, right? What we are going to do is we are going to start, the way we calculate it is from 0. So your unsigned integers can store values from 0 to 2 raised to power n, right, minus 1. Right. So in this case, if we have 8, literally means so if we have 8, right, literally means we can do 2 raised to power 8, right, over here. Then 2 raised to power 8 minus 1 is 255, right? So that means if you store 255 here, it can contain it. But if you store 256, right, it throws an error saying that it is implicitly convertible to expected type uint 8. Literal is too large to fit in uint 8, right? And so what that means is that we've been able to calculate the range of value that this can store, right? Which is it can store value from 0 to 2 raised to power the variation, which can be either 8, 16, 24, 32, or 256, right? Then minus 1. So in our case, we have 0 to 2 raised to power 8, which is 256, then minus 1, which equals 255, right? And so that means that this can only store 255, but can't store 256, right? So these are some of the things that we need to be careful of when we are working with signed and unsigned integers, basically, because it might lead to some sort of overflow or underflow, right? So we need to be sort of careful of what's like the maximum value each variation of our variables can hold, especially when we are working with integers or unsigned integers, right? Moving on. Oh, awesome. Okay, coding along. Oh, great. May I know? Yes, we'll have assignments. Yes, we'll have assignments for sure. Kindly stick to the end. We'll have assignments. So moving forward, we've been able to like understand signed and unsigned integers, right? Moving forward, let's take a look at the various operators that you can use for both unsigned and signed integers, right? Just like every other like mathematical operators, you can use greater than or equal to, the bit operations, shift operations, basically do like additions and multiplication, modulo, exponentiation, right? Basically, every type of like mathematical operations that you can do, you can also do them on like your signed and unsigned integers, right? So let's move to the next primitive data type, which is like Boolean. Your Boolean is declared with the bool keyword, which is bool, right? It's declared with the bool keyword, right? And of course, just like every other programming language, your Boolean takes two possible values, which is like true or what or false, right? So meaning that when you declare a bool keyword, it can either be true or false, right? So moving forward, I talked about how that every data type, especially in Solidity, have their default values. And for signed integers, it's 0. For unsigned integers, it is also 0. But for Boolean, it is false. So your Boolean becomes false by default, right? It's false by default. And the size of a Boolean is 1 byte, right? Also, like the size of a unit 256 is 32 bytes, just like we saw in the previous slide. And we can use various operators, right? Like the and or strict equals to and whatnot, right? Let's quickly demo that also on Remix, right? Let's say bool. Then our bool, we can set it to over 18. Right, let's say this equals true, right? So this is practically how to declare your Booleans, right? So this is us trying to form our smart contract. We're already understanding some of like the data types. We've seen how to use signed integers and how to use unsigned integers. Now we are talking about Booleans, right? Because when you're trying to write business logic, you might have to work with some of these things where you have to store numbers or integers, or where you have to store like if something is true or if something is false, right? So these are like the data types that you need to, have at the back of your mind, right? Moving forward, I think we can also set this to false, right? As you can see, let's set it back to true. Moving forward, let's also talk about the next one on the slide, which is address. Now, I know that quite a number of us must have, seen an address, right? When we did the first assignment, how that you downloaded Kaia Wallet, you went to the file set and you got 50 Kaia, you provided your address. Now, so this is like one of the practical use case of address, right? Where your address is an identity on chain, which basically helps you do stuff, right? Initialize transaction, sign transaction. It's basically like the public facing identity on chain, right? So when you're writing smart contracts, you'd also have to deal with addresses, right? Where you won't have to store the address of a particular customer. In the case where you're writing a bank smart contract, or you're trying to store, an address as a key value to a customer, right? So in that case, how do we declare an address? An address is declared using the address keyword, right? An address is declared using the address keyword. Just as we have seen in other instances, we use uint, int, we use bool. For address, we use address. It's as straightforward as such, right? What do we use address for? You can use an address to store whether your account, your EOA, which is an externally owned account, just like we created on Kaia Wallet, or a smart contract, right? So there are two types of accounts on the blockchain, your EOA and your smart contract accounts, right? So each of these two are a separate bit of addresses. One has code, one doesn't have code, right? Your address can also be address or address payable. When we say address payable, the payable keyword basically means that it can accept Ether in this case, and it has more methods like send and transfer, right, compared to just address, right? And the size of an address is 20 bytes. Just like every other data type, it has its own default value. The default value for an address is address 0, right? Address 0, which is 0x with like 20 bytes, right? With 20 bytes at the end. Pretty much Now let's see how to declare an address. So we can say address, which is the keyword, and we say the name of the address. Let's say owner, right? So this is me basically just declaring an address variable and also initializing it with a value, right? So far, this is what we've been able to do. And also an address can be payable, right? We can say address payable, right? We call it admin, right? All right. As you can see, this is not, when I pasted an EOA from MetaMask, it automatically just throws an error, and it's telling me something around address is not implicitly convertible to expected type address payable. As you can see, this is an address payable. So we need to convert this also to an address payable. And to do that, I just need to wrap it around the payable keyword and the error is gone, right? Pretty much how to declare an address and also an address that is payable. And mind you, this address has two functions that can help you transfer and can also help you, send whatever value that is in this address, because it can accept Ether, right? In this case. Now, moving forward, let's take a look at the next primitive data type, right? Which is enums, right? What are enums, right? Enums can be used to create custom types, right? With like a finite set of constant values. What that means is that we can create like a custom type of data that is not, that doesn't exist in all of like the data type that we've just mentioned, basically just to suit our use case. And it has like a constant value, at each time, right? So an enum is, in practical terms, right, we can use an enum to, keep track of states, right? When something is loading, when something is in progress, especially for like a supply chain contract, right? You might want to write an enum that keeps track of when it's in production, when it's currently under delivery, when the payment has been made for, the goods, when it's being delivered and when it's being bought, right? So an enum is a way for us to like write custom data types or custom types and set constant value to them in this case. But how do we declare enums? Basically by using the enum keyword. And just like I mentioned previously, it is a user-defined data type. You get to define what type of data you want it to be. In this case, it might be progress, it might be delivery, it might be, let's say, done or whatever, right? Ideally, right, it's used to limit variables to a predefined value. Like I mentioned, you are trying to like limit a particular variable to like the value that you set, depending on your use case. Take, for instance, if you are building a to-do smart contract, right? A smart contract that helps you track your to-do list. Now, your enum would have a type of created, then it will have an enum of ongoing when your task is currently ongoing. It will also have an enum of done. So these are like example of 3 custom types that would be in your enum, right? Because this is what you want your to-do smart contracts to have. So it speaks to the fact that an enum is like a user-defined type, depending on like the use case, whether you're building a supply chain smart contract or a to-do smart contract, or even like a token smart contract, right? You want to keep track of the state when a token is minted, when a token is burnt or whatever. So you can use like an enum to define these various data type and also set, predefined values to them. Now let's take a look at how enums are declared, right? Like like the slides mentioned is declared using the enum keyword, right? And once you use the enum keyword, what's the next thing? You basically specify the name of the enum, let's say to do, right? And you declare, um, let's say start, ongoing, and finish, right? So this is how you declare your enum, and your enum can, like I mentioned, have various predefined value. So this is our predefined value: start, ongoing, finish, right? You can also set your enum to have a default choice, right? In this case, the first value in your enum is the default choice, right? Which is start, right? So whenever you're trying to access your enum, the first thing it uses is the start, right? But we can get to like alter this by basically just saying, and I'm going to be using some sort of like new keywords, right? Going to explain some of them in like a later session, right? But however, do bear in mind, mm, so we can set our constants, or we can change our constant value to be a different value. And this becomes, the default choice. Now, before line 25, right, our default choice or our default starting enum will be start, right? But because we've written line 25, we set it to a constant, and we said the default choice is going to be to do dot ongoing. So this becomes our default choice when we start using it in whatever function or wherever we want to use it, right? Pretty much how to declare an enum. And so for primitive data type, right, the last on the list is bytes, right? For quite a number of us, I think from the last assignment, we saw transaction hash, we saw quite a number of things. We saw block hash, we saw some of these things, right? Now, your bytes is like a representation of some of these stuff that you have seen on Kaia scan, right? This is the data type of your transaction hash bytes, right? Especially for hashed values, right? It's a byte 32. Now, for the way we declare bytes is that it is declared using the bytes keyword, and it ranges from byte 1 to byte 32. Now, in the case of like a transaction hash, it's a byte 32, right? Now, we mentioned that we can say bytes. As you can see, it's bringing out various bytes ranges from byte 1 to byte 32, right? So we can say this is byte 32, right? Equals Keshak 256 ABI dot encode, let's say owner, right? So we have to declare the name. Let's say hash, right? Yep. Now, when we want to change this to, let's say, byte 31, it throws an error, right? It says byte 32 is not implicitly convertible to expected type byte 1. Now, your Keshack 256 returns is basically an hash function. You know, I mentioned in our first class that there are various hash functions that we can use, right? And the one that is used in Ethereum and quite a number of like other EVM compatible chains is Keshack 256, right? And so far, this is us implementing Keshack 256, and it basically just hash does value, and it returns a byte 32. So we expect to also provide the type to be byte 32 before this sort of like pass, right? So why are we doing all of this? We are doing this because we need us to understand that contracts are just like class in object-oriented programming. And we need to be able to, for us to encode our business logic, we need to understand various data types such that it kind of like inform our logic, or it sort of like informs how we encode or how we write business logic on chain. So if you are trying to write a bank smart contract, you basically just know what you need. You, of course, need an address, right? You need uint because uint stores values, right? You need an address because an address basically stores the value that will be deposited, or in this case, and also helps you send money out in this case. If you are using a payable address, you can transfer in this case, right? And that's just a simple scenario. So this is our basic smart contracts using all of the primitive data type. Do we have any question? So we can put any random address. Yeah, I mean, when initializing, you can put any random address from whatever wallet, whether from Kaia Toolkit, just like how Neo mentioned in the last class. You can click on the generate button, or from MetaMask. And now, for the most part, we can use a global variable called msg.sender, right? So this is what you'll be using mostly. So we've not gotten to this part, right? I think we can revert back to our previous code. Do you have any questions so far? What is the difference, Brew? Not sure I got that question. Okay, what is the difference between transfer and send method? Okay, so the transfer and send method in address payable basically is that the transfer method reverts when, there's a failure. Probably you don't have gas to like send, or you don't have money to make the transfer. It basically just reverts, right? But for send, it returns Boolean, right? And that would mean that you have to be able to cater for this. So if it returns Boolean, right, it is not going to revert if you don't have enough money to send. It just returns false, right? And so as the smart contract developer, you have to be able to handle the error case by writing a require statement that if it returns false, right, then you should throw an error, right? And so that's like the difference between transfer and send in this case. I hope that answers your question. Why did you declare Keshack 256 in bytes? Okay, so Keshack 256 is an hash function that basically returns a byte 32 value by default, right? That's like the return value or the return type. So that would mean that if we are declaring any type of data to use this return value, it also has to be byte 32, right? Because the return type of this function is by default byte 32. So whatever variable that wants to use the return value needs to be byte 32. Um, I hope that makes sense. Yep. Do we have any other further questions? Oh, okay. Please, which is the best, or it depends? Okay, so actually the best is using call, right? According to like Solidity documentation, um, when you're trying to do sending of ethers from like address, right? The best is to use call, right? I know we've not talked about call in this case, or like yeah, call or delegate call or whatever. But when you're trying to send ether, right, the best is to use call. So we have something called low level call, right? So what that means is that it takes in the value you're trying to send, and you also have to handle the return the return value. But by best practice, what you need to use is call. So you have to either not use transfer and also send, right? I think in like a later session, I'm going to also like explain call and also delegate call, and how we can use this in first sending ether, or like doing delegate calls to like other smart contracts. Hopefully. Awesome. So yeah, I think that's for the first part. Let's quickly, change our smart contract. So this is our simple smart contract, right? So far we have all of this, right? Now let's rewrite our simple smart contract to be basic, because we want to deploy using Remix, right? So let's contract. Let's call this basic, right? The first thing we want to do is declare a signed integer, right? So we say int, then we put the visibility, right, which is public. Now, I know we've not talked about public, right? But the public keyword basically means that this variable can be accessed by anyone, both the contracts and any other external contract, right? And by default, a public variable automatically have a getter function. When we say getter function, a getter function is a function that returns the value of that variable, right? So for visibility purposes, when we are trying to deploy, it just makes sense to put this in public, right? Such that we can see the value of each of the integers when we deploy. We'll see why this is important in a minute, right? So let's call this number and set it to -10. Moving forward, let's also declare our unsigned integer. I hope that we are all coding along. Unsigned integers. So who can tell me the value of, or who can tell me the range of line 7? Is there anybody that can tell me the range of line 7? Let's call this balance equals 200. Is there anybody that can tell me the range of line 7 in my contracts? Anybody? Anybody wants to try? So we mentioned that every integers, every signed integer, unsigned integers have range, right, in steps of 8, right? But in my case, I did not specify if it's uint 8 or uint 14, or sorry, uint 16 or uint 32 or whatnot. What do you think this uint will be? What do you think the range is going to be, or this integer? Anybody wants to try? Kingsley. Oh, awesome. It's 256. That's brilliant. Thank you very much. And so we mentioned that, the default value of, or sorry, like the default range of, int 256, or an int keyword is what? Int 256, right? And in the case of like uint also is uint 256. Thank you very much for answering that question. So that means that we are following along. And so the next part is to also like declare our boolean, right? So we have bool, and we call this private. Let's set this to public. So there are various visibility types. We have public, we have private, we have internal, and we also have external, which we basically just use for our functions, right? But I think we're going to take a look at this in like some or later like lessons during the bootcamp. But in any case, let's set this to public is active, right? Let's set this to true, or let's set this to false, right? The next part is to declare our owner, right? Address public, let's call this owner. And for now, we are not setting anything in the owner, just like we did previously. The next part is to declare our enum, right? And let's call this face, right? Start, ongoing, then finished. Pretty much. Once that is done, also we want to set our enum to another face. I mentioned that the default of an enum is usually the first in like the enum list. And so for this part, it's going to be start. But if we want to change the default, we can just basically say face constant default face equals face dot ongoing, right? We can get to also set this to public. So face constant public is default face equals face dot ongoing. So this becomes our default face, right? Ongoing, other than start. Now let's take a look at the other primitive data type, which is byte 32. So this is us basically just saying how to declare them, right? In this case, so let's set this to bytes 32. Name, should we use name or owner hash value? Equals Peshak 256. And then the next one that we talked about, I think that's like all for all of the primitive data types that we looked at, right? Pretty much it. Now let's write some functions, right? Let's write function to to change our face and also to change our owner in this case. Now, in simple terms, your functions are reusable piece of code, just like in every type of like programming language, right? It's a function is a reusable piece of code that is used to either read the smart contract, write to the smart contract, basically just mutate smart contracts, right? Mutate the value of a particular data in a smart contract, or even to return values, right? So this is what your function is. It's a reusable piece of code that helps you to either query or mutate data in your smart contracts, right? And the way to do that is that you use the function keyword followed by the name, right? And also it has an optional return value. You can either return value if you want. This might seem like quite a lot. So the thing is, I'm just going to, write some of the functions that we might need for this contract before we deploy it. And then in a later lesson where we are talking about functions, then we can understand in depth, right? So we want to write a function that change owner. So we're going to call this change owner. And in this case, we need to pass in the owner, the new owner that we want to change it to. So you have to pass in address and call it new owner. Now, when you're trying to pass in parameters in your function, it's advisable to use the underscore. It's advisable to use the underscore to like the parameter name, because it sort of like differentiates your variable from, or it sort of like differentiates the parameter in your function, such that even if you have like a variable that is also called new owner, I mean, this is like a different variable name, right, or parameter name. So we can set this to public also. It's just basically convention, right? Whenever you're trying to pass in a parameter, use an underscore, right, to the parameter name. It's basically just a convention. So in this case, we want to set our function to public, right? Like I mentioned, your public function means that anyone can access this function. It can be called by this contract or any external contract, right? So pretty much it. Now we want to set our owner to be equals to this new owner. So we basically say owner equals new owner, right? With your semicolon. So this is how we basically just write a function to mutate the state, right? But in this case, what we did was to declare the function, keyword, the name of the function, the parameter, and the type, right? Because Solidity is statically typed. For every data that you're working with, you have to specify the type, right? And we also set the visibility of the function. We set it to public, right? And then our curly braces, then this is line 26 is basically mutating the state owner and setting it to a new state, new owner, right? Pretty much. Now we want to write another function also that sort of like change our face. So we're going to write function change face. We call this the type, which is face, and we say public. And so we say default face equals face, right? So this is pretty much how we change, but this is a constant value, right? It cannot be changed except we remove this, right? So now we can basically change our face, right? Pretty much how to change your face, right? Which is our enum. Also, we can write a function to to toggle our Boolean, right? Toggle active. Just like every other function declaration, the function keyword, the function name, parameter if you want to have some parameters, the visibility, and sometimes you might have return type, right? If your function, or if you want to return a particular variable from your smart contract, you have to set the returns, right? You write a function that returns the variable from your smart contract in this case, right? But in this case, we are not returning anything, right? So what we basically just do is we set is active to be equals to not active each time. So when we call this function, if is active is false, it turns it to true. Then if it's true, it turns it to false. So it basically just toggles our Boolean. So this is pretty much all of the example of the primitive data types that we've seen so far, from signed integers to unsigned integers to Boolean to address to enum to bytes, and then we basically just wrote functions, right, to mutate or to read from the states. Having said that, let's deploy our smart contracts. Right. So to deploy your smart contract, like I mentioned before, you have to go to your deploy and run transaction tabs, right? What you want to do is to change your environment. You click on this and you use injected provider. And so for this guide, I think we are going to use not sure. All right, I think we are going to use Kaia plugin. Now, so if you don't know how to install your Kaia plugin, you can go to Plugin Manager once more and just type Kaia and activate the Kaia plugin. So I'm going to be using Kaia Wallet in this case and just use injected Kaia Wallet, right? Let me try to reload my remix. It's taking a bit of time. All right, so this is my basic.sol, and I just want to go to Kaia and then load injected provider Kaia wallet. So it has loaded my account, as you can see, from this part, 0x7d3c 0x7d71, which is this guy, right? So that's pretty much how to connect your Kaia wallet to your remix and basically just deploy. As you can see, our contract has been automatically compiled. Like I mentioned previously, once you've written your smart contract, the next thing you want to do is to compile. And we have already compiled because we set our compiler to auto-compile, right? And so let's head over to the deploy and run transaction tab using Kaia. And all you have to do to deploy is to click on the deploy transaction or the deploy button, right? And this is going to pop up a request to sign or to confirm your transaction. Once this is done, you basically just deploy your contracts on the Kairos testnet. Because I'm currently using Kairos. I'm currently on the Kairos network. You can toggle to switch. If you want to deploy on mainnet, you can just switch the network to mainnet in this case, right? Pretty much it. As you can see in the deployed contracts tab, we have a full, or like we have a UI to interact with our contracts, right? And so if you copy this, it's going to give you your contract address, right? So I'm just going to paste this here. So this is our contract address for our basic Solidity file, right? Pretty much it. So from here, we have seen how to, write a contract, how to compile a contract, right? Using the Solidity compiler tab, how to deploy a contract using the Kaia plugin by switching your environments to injected provider Kaia wallets, using Kairos testnets, and then, deploying by clicking the deploy button over here. Now, for some reasons, I also want to explain some of these fields. It has gas limits. It also has value. In the case where you want to send in Ether into your smart contract, you are going to use this value field, right? Also, if there's a fee payer for your configurations, right, you want to import your fee payer over here, right? If there is a constructor argument, you're going to see an option or a field to insert your constructor argument over here. But because this contract doesn't have a constructor, we are not saying that, a constructor with a constructor argument in this case. For the sake of those who don't understand, the constructor is like a one-time function that is run to basically initialize your contract, right? So it's usually run at deployment time. Most times you might want to initialize your smart contract with certain variable or with certain data in this case. So your constructor is that one-time function that is used to initialize your smart contract data. I hope that makes sense. So now that we have our contracts deployed, we basically want to check everything. As you can see, we have the norm right over here. When we check the number, it should return -10, right? Which was what we wrote here. If we check active, it should return false, which was what we did set here. And if we return, or we click on the owner, right, it should return address 0. Can anybody tell me why this is returning address 0? Yeah. Kingsley, this question is to you. You mentioned that, please, what is the default value of owner address when it is declared? What do you think the default value will be? I think we mentioned in like the previous slide, exactly address 0. So when you declare a function or like a variable type, yeah, I mean, this is not the deployer in this case, right? So like I was saying, when you declare a function, right? I think to Johnson's thought process on this, because I did set it to the owner, right? But I did not set a constructor that sets the value to msg.sender on deployment. So that's why it's not the deployer. But what I did was I declared an address owner and I did initialize it. So we mentioned in the previous slide that when you declare if a variable with a particular data type, it has its default value. And so because I didn't mutate or I didn't initialize owner, it returns the default value, which is address 0, right? I hope that makes sense. But now if I get to change the owner, so the only way for me to change the owner is by transacting or by calling a new owner. So I can pass in the deployer address, which is 0x7d3, and paste it over here and transact. This is also going to pop up a notification on your Kaia wallet for you to confirm your transaction, because you are writing to the blockchain state. You need to pay some gas to ensure that this happens, right? Once that is done, when we try to check owner, it should have changed to the value that we set it to, right? And so this is, the idea behind smart contracts, right? Where it's in the format of a class that has various properties, various data, and also have various methods that can be used to either reference those property or mutate those property. Now, same thing applies in this case. We've been able to look at the primitive data types that we can use in smart contracts, from signed integers to unsigned, to booleans, to address, to enums, to byte 32. And we touched a little bit on functions to of course, in this case, mutate this variable types or like variable that has been declared. Now, having said that, let's quickly take a look at this on the Block Explorer, right? So the Block Explorer is more like your search engine, just like Google. But in this case, your Block Explorer, I think some of us must have, interacted with the Block Explorer. It helps you to like look up transaction, contracts, and token addresses, whatever, everything that has to do with the blockchain, right? It's like the Explorer is the go-to place to look up everything that has to do with the blockchain. And so in this case, now that we've declared or we've deployed a basic contract, we can go to the Explorer and look up our deployment transaction. That's me. So, yep. So this is our transaction hash, right? Sorry, this is our address, right? And this is our block explorer. As you can see, there's a transaction hash, right? 2 minutes ago, it was deployed from 0x7d, which is the same address that is over here, 0x7d3c. And we basically just created a new address, which is 0x74 and whatnot. And so, yeah, that's pretty much about, compiling or writing smart contract on Remix, compiling the smart contract, and also deploying the smart contract using the Kaia plugin. Now, in all of this, we've talked about the primitive data types. Now, which are also called value types. Now, why are they called value types, right? They are called value types because values can be assigned to them, right? So when we say values can be assigned to them, and also it means that you can directly store value in them compared to like reference type, where in this case, a pointer to where the data is stored is actually referenced. So it basically points to where the data is stored, not necessarily storing the data itself, right? I think I'm going to explain that in the next slide, right? So we've practically done like some demo on Remix, and so far let's move to the next part. But was any of us able to deploy on Remix for those following along? Anybody? Okay, please, can you share like your contract address over here? So for as many of us that was able to follow along, can you share like your contract address in the chat, right? Before we move to the next part. I'm still waiting. Awesome. Samson, were you able to deploy? Oh, I see. Okay. So let's just quickly move on. Please endeavor to like test out some of these things, later on when you now have your laptop, right? Oh, awesome. I think Johnson already shared his contract address, so let's check. Thank you very much, Johnson. So we have 3 minutes ago from this address, 0x, this guy. Okay, so that means you claimed your 50 Kaia the other time from the last assignment. Awesome. So yeah, set count. Okay, cool. Amazing. So moving forward, let's okay, Samuel. Yes. So anyways, we'll be having like an assignment after the class. So I think it's going to sort of like help you further understand, the concepts of what we have been talking about and whatnot. So yeah, I think I'm going to share the assignment after the class. So thank you very much, guys. Moving to the next part, which is like reference types, right? So what are reference types? Um, just like I was mentioning, right? A, we said that we have two data types, right? We have value types, which are also like called like the primitive data type. So a value type is a type of variable type that's basically like assign value to the variable on the go, right? They are stored directly in storage, and depending on whatever like data location that you do set for it. But for reference type, what it does is that it stores the pointer to where the variable is actually stored, right? And so what does this mean? Now, the way the EVM works is that for the most part, you can store variable in like two places, the bytecode and also the storage slots, right? Which is storage. And so storage has like various slots, and for each slot, you can store up to like 32 bytes in each slot. And this might be quite a little, over what we are talking about right now. But what it means is that for every type of variable they are trying to store in storage, right? What DVM does is that it kind of like stores them in storage, and each of these storage have different slots. Take for instance, a UINS 256 will fleet or will fill up one storage because it's 32 bytes. Now, each of the storage slots can contain value up to like 32 bytes. And so because UINS 256 is 32 bytes, it's going to also fill up, the storage slots of 32 bytes. For the most part, for like reference type, right, or for like value type, how that we get to retrieve values from the storage in the case where they are stored in storage is that you get to just look them up and they are in their storage position. Take for instance in this case, this is in 256. This is in slot 0, right? This is in slot 0, right? This is in slot 1, right? And what this means is that you can easily say that you can tell the EVM that, oh, help me get the value in slot 0, and it returns 10. But for reference type, right, it's not the same. Reference type basically stores a pointer to where those variables are stored, right? It basically stores the pointer. When we say pointer, we mean that whether an hash value in this case, take for instance, the way those EVM kind of like stores mapping value is that it kind of like hash the slot and the key, then this is what becomes the storage slot in this case. And so because a mapping has various key to value pairs, we're actually going to see that in a minute, right? The way the EVM stores them is that it kind of like it hashes the slot, which in this case is like, let's say slot 1, then also hashes the key, which is an address, then this is the pointer to where this value is stored in the EVM. So that's why we said like reference type most times stores a pointer to where, the variable is stored, and it doesn't just store them, directly like value types in this case. I think I'm still going to like do some sort of like explanation, but when we are going through like when we are doing some code along sessions or whatnot. So yeah, pretty much it. Now, what are the various reference types? We have arrays, we have mappings, we have structs, we have strings, sort of. Now, these are complex data types, like I mentioned previously. These are complex data types. Now, when we use reference type as a variable, we need to specify their location. For the most part, quite a number of like variable are stored in storage, right? But for some other reasons, we have to also specify where some data are stored, right? And so there are three types of data location that your reference type can be stored. One is storage, right? The second one is memory, and the third one is call data. Now, when we say that a variable is stored in storage, right, what does it actually mean, right? When a variable is stored in storage, it means that it is persistent throughout the life cycle of the contract, right? Meaning that you can't, it's stored in the contract lifecycle for as long as the contract exists, right? And that's what we mean by a contract or like a variable being stored in storage. The variable is persistent throughout the lifecycle of the contract. Now, when we say that a variable is stored in memory, it means that that variable only exists only when the function is running. And so once the function is executed, the lifecycle is terminated. Now, for the most part, I think quite a number of like variables that are declared or that are stored in memory are usually used in like function calls, right? Where you need to set a type of variable and also, yes, where you need to set a type of variable and the variable only exists within the function call. So take for instance, you might declare a variable get balance, right? And probably you're trying to also calculate some, okay, let's do it this way. You have a function called sum, right? You are not trying to read variable from the state, right? Right. Mind you, any variable that is stored in storage is called a state variable, right? In this case, when you're trying to write a sum function and you're not trying to read from the states, you can declare a variable within your sum function that only exists within the function call. And so to do this, you have to declare that variable in memory, right? So in this case, you might write a function that sum up all of the value in an array. So that means that that array has to be in memory, and you have to initialize that array within that contract to get the sum of all of the values in the array. So the value in the sum of the value in the array only exists during the function call and is not stored and is not persistent throughout the life cycle of the contract. I hope that makes sense, right? And so to the last one, which is call data, right? This is a special data location, usually for function arguments, right? Especially external functions, right? This is where you sort of like store your external function arguments. Now, it is non-modifiable, right? You can't modify the value that has been stored in a particular data that is specified to be in call data, right? But for storage, of course, you can mutate it, right? And so these are like the differences between the various data location. We have storage, we have memory, we also have call data. I think in recent time, right, Solidity introduced something called transient storage, right? You can take a look at this, but it's basically that the variable that is stored in transient is also is in storage, but it exists only throughout the life cycle of the transaction. So once the transaction is done, it's no longer persistent, right? So these are like examples, but the three major ones are like storage, memory, and call data. So I need you to have this at the back of your mind when you're writing your smart contracts and when you're dealing with them. So the next part is to explain some of these reference type, right? We mentioned that we have structs, arrays, mappings, and also strings. And so let's talk a little bit about struct. What are structs, right? Struct is a user-defined data type. Is like a bigger brother to like enums, right? We said that enums are custom defined data types with like constant values, right? While struct is also like a user-defined data type, right? You get to specify what type of data that you need to impute in this variable type, right? And so with struct, it allows us to group multiple variables together, right, under like a single name. So imagine you're trying to write a smart contract that, or like an attendance smart contract, take for instance for this particular class. That means I need to be able to write a struct that groups multiple variables together. Take for instance the name of the attendant, when the attendant or when the participant join, when the participant join, that's the time. I need to specify the name of the participant, the time they joined, and probably other details like how old the participant is and whatnot, right? So that means you have to house all of this data in a single place. And the way to do that is using structs, right? Pretty much, how do we declare structs? We declare structs by using, of course, the struct keyword and also the struct name in this case, and with your curly braces, and then other types of, will I say, the various data types that you want to pack together, right? A struct can be declared in and out of a contract, pretty much. But let's see how, you can declare a struct. So what we want to do is we want to, yeah, let's write a new file. Let's call this reference.sol. And let's do pragma. All right, and so the way to write, let's declare structs, is by saying, using the struct keyword, right? First of all, and then the name of the struct, let's say class, right? Then your curly braces, right? In this case, we want to set the various values that we want to pack together, right? We mentioned that a struct can be used to, pack various or multiple variables that you want to store in a single struct class or a single struct type. In this case, we want to add address, right? And we say address. Mind you, for every data that you want to declare, don't forget to always add their type, right? Address type. We also want to add uint, want to add their age, right? What else? The time. Let's add uint time. Let's add Boolean. Are they over 18? Right. So let's deal with this for the start, right? So this is how we declare a struct class. Sorry, a struct type. And our struct type in this case is a class, is named class, right? moving forward, now, how do we initialize a struct? A struct can be initialized in 3 ways. When we say initialize, it means that how do you like set the values in each of these guys, right? So it can be initialized in 3 ways. Now let's take a look at how a struct can be initialized. We can say function set class. Let's call this set class 1, and we want to pass in all of the parameters: address, uint, age, right? Uint, time, and also bool over 18. And so we want to set this to public. And so for the first time, we'll be using returns keyword because we want to return our struct. That would mean that when you are declaring your returns keyword, you have to specify what data type you are returning. Now, we want to return class, memory, right? Sort of like mentioned that when you are dealing with structs, right, you have to specify the data location, right? So this is what we just did. When we are returning the class, we specified the data location to be memory, right? Which means that we have to, so the first way to initialize a struct is to you call it like a function, call it like a function, right? Which means you just basically do return class and call it like a function and pass in address, age, time, and also over 18. Right. So this is the first step, right? This is the first way to initialize your struct, right? We basically just call it like a function and pass in all of the value, address, age, time, and over 18. And as you can see, this is throwing like a sort of warning. It says that function state mutability can be restricted to pure. So we can restrict this to pure. Quite a number of these things we have not talked about it, like pure keyword. A pure keyword means that it can neither mutate the states or read from the states. When we say states, it means that reading from the states variable or writing to the states variable. Also, later on, we'll use a keyword called view, which means that it can read from the states variable, but it cannot mutate the states variable, right? This is the difference between pure and view. A pure function can neither read or mutate the state variable, right? In this case, as you can see, we are not reading from any state variable or writing to any state variable, right? And so for a view function, it basically reads from the state variable and it doesn't mutate the state variable, right? Pretty much. So why is that? The reason why we're using pure here is because this class only exists throughout, the function call, and that's all. All right, so pretty much that's the first way of declaring a struct or like initializing a struct. The second way is by I'm just going to copy the first one, right? Is by call it like an object key value, right? Key value pairs. So which means that you basically have to use the object, just curly braces, and say, what is the key? The key here is address, right? And the value is address, right? Next one, the key here is age, and the value here is age, right? Next one, the key here is time, and the value is time. Then the last on the list is over 18, and the value is over 18. And so doing this, we've been able to, call or initialize our structs in two ways using like the object's key value pair method. The third way is to basically just initialize it directly, right? How do I mean? By assigning values to it directly. Assign. So yeah, we can say class memory, then specify the name, right? And say c.age or address equals address, right? c.age equals age, c.time equals time, and c dot over 18 equals over 18. So these are like the three ways we sort of like initialize a struct by calling like a function, using like the object's key value pair method, and just assigning values directly, right? If we get to deploy this in our Remix VM, which is like locally, right, we are going to see the first part and also the second part and also the third part. So if we want to do the same for everything, I think we can just copy age 18 time. And so as you can see, it sets all of these things to, what's it called? To each of the respective fields in the struct, right? If we tend to do the same over here, age 10, false. So it basically just sets the value to the struct, right? So this is like the way to initialize your struct value, right? So it has the address, the age, the date or the time, and also if it's over 18. Yeah, so pretty much this is how you declare your struct, and this is how you initialize your structs using these three methods, right? I hope that makes sense. Moving forward, we have arrays, right? What are arrays? For quite a number of us who are like familiar with other programming language like JavaScript, right? Arrays are used to like store elements of same data types, right? You have a number, right? And you want to store all of the numbers in the same place, right? You get to use array, or you have an address and you want to store quite a number of addresses in the same place, right? You use address. So arrays are basically used to store elements of same data type. So when it comes to arrays, especially in Solidity, it has two types: a fixed size array and a dynamic size array. Now, what is the difference between a fixed size array and a dynamic size array? A fixed size array has a fixed length at the time of declaration, while a dynamic size array doesn't have a fixed length at the time of declaration. Now, what does this mean? It means that a fixed array can have like a fixed length of 5 or 10, right? While a dynamic array keeps growing, right? It's not limited by the length. Say, oh, we can only house like 5 values here or 10 values here, right? Also, the members of an array, just like every other programming language, is push to add a new array, to add a new value to the end of the array stack, right? And also pop is to remove like the last value from the array list, and also length returns the length of the array, just like every other programming language. So for the sake of those who don't know array previously, the push, just to reinstate or just to restate, the push method adds a new array value to the array list, right? While the pop value removes a value or the last value from the array list, and the length returns the size of the array list. Now let's take a look at how an array is declared, both fixed size and dynamic size, right? Fixed size. So a fixed size array, take for instance, if we are working with a uint, is declared as such, and we declare 5. So it means that it can only contain 5 values, right? This is a fixed size array. In the case where you don't know how many value or how many items you are going to be pushing to your array, you can use dynamic size, right? But in the case of, I'm sure that my array is going to have, take for instance, 17 participants, just like how we have on the call right now. I can set this to, 17, right? Pretty much, and I'm good to go. So this is fixed size, right? So once you have declared that, you're going to say the name. Well, let me declare this to be public, and let me set the name to participants, right? Equals, so this can have values from 1, 2, 3, 4, 5. If you try to set a value more than 5, it's going to throw an error, right? As you can see, it says that uint 8 sys memory is not implicitly convertible to expected type uint 5 storage. Right? So because you did set a fixed size, it's saying that you can store value up to 6. But if we get to change this to 6, then it can contain 6 values, right? The next part is dynamic size, right? So a dynamic size array basically just takes, the value as such, and you can just set whatever, from 1 to like whatever, and it keeps like containing those values because it's a dynamic size array, right? So that's that about fixed size and dynamic size. But usually we have scenarios where we get to declare arrays in a function. So when we are trying to declare an array in a function, it has a method of initializing it in a function. When you are trying to use array in a function, we get to use the fixed size arrays, right? Because we want to be sure of the length of the array in this case. So we do something like function. So I'll first talk about how arrays are declared in a function using like the fixed size array, right? Then let's do something like get some public view. It's going to be pure returns uint. So let's see how we declare an array within a function using fixed size array. So we do something like uint. Then we say the name, or like not the name in this case, where we want it to be stored, then the name. Let's call this s equals. Then we use the new keyword, new, then uint, and also the fixed length, right? So this is how we declare an array within a function, right? This is the array type with the data location. Then this is us initializing it to an array that is of fixed size of 5. So this is currently throwing a warning because it's like an unused local variable, right? Right. So now let's basically just set our array. So we do S0 equals 1, S1. And mind you, arrays are zero-based index, right? So to access the value in the first array list, you have to do x0, right? Then 1, and so on and so forth, right? So this is us setting the value, setting our array, or declaring our array, declaring our array within a function. And this is us initializing the array within, right? So now that we've done that, now the next thing we want to do is, because we want to return the sum of all of this value, let's declare a sum, a local variable called sum. We call this unit sum and leave it uninitialized. Then we want to write a for loop that loops the value of S, right? That loops all of the array list in S and kind of like returns the sum of all of these guys. And so to do that, we're going to run a for loop, right? And we say uint I equals 0, right? Then the condition is that I is less than S dot length, right? And then we want to increment. What we want to do is we say that sum equals I basically just return the sum. So what this is doing is basically looping over this array list and setting equals plus or equals to, yeah, plus equals to si, right? Each of the value in each of the indexes. So when I is less than s dot length, it goes and check, then brings the value in whatever index that is here. And it does that until I finishes like the length of the array in this case, right? So this is how we basically first declare array within a function, right? And also initialize the array within the function. You set the array type, right? Uint with square brackets and the data location with the name. Then initialize it by using the new keyword, uint, and the fixed length or the fixed size of the array. So this is just basically playing around. And when we get to deploy our contract to the local VM again, and we call get sum, it returns 15, right? Because it has been written to add up all of the values in 1, 2, 3, 4 in S, right? And so if you do the sum of 1, 2, 3, 4, 5, it's basically 15, right? And so this is an example of how to declare an array within a function. Right? We also mentioned that an array can have various methods like push, pop, and also length, right? We saw how we use length here, s.length. I think you can also play around using push. It basically helps you push a new value to the end of, so take for instance, we can write a function, add value, and call this uint and say num, and we do public, right? And so what we do is we say student, in this case, student.push, right? We push num. And so this is how you get to like push new values to your dynamic array. right? In this case, and same applies to pop. You can also use pop and just, do stuff. I hope that makes sense. Moving to the next one, which is mappings, right? Yeah, so what are mappings, right? Mappings are basically like a data structure, right, that sort of helps us store values in them in a key value pair format, right? And so the way you can think of mappings are like it has a key and also a value pair, right? So for the most part, it's a data structure that helps us to like store data in them using like a key value pair format. And so the way we declare mappings is that you use the mapping keyword, of course, then it has a key type and also um, a reference to the value type, right? So that means to be able to access the value type, you have to provide the key type. Or to be able to set the value type, you have to provide a key type. All right. And so a key can be any built-in type plus bytes and string and not reference type. So when you're writing your mappings, you can't use a reference type, but you can use any type of value type, right? Pretty much. Also, your value can be any data type, meaning that any value that is being associated with a key can be any data type, right? An example is if you're writing a bank smart contract and you want people to deposit, how do you keep track of each user's deposits, right? The way to do that is to use a mapping where you map the address that is sending the deposits to a UINT that kind of like tracks the balance. So each time somebody deposits, you are going to increase the value of the balance, provided you have the address, right? So that's pretty much it. Let's take a look at how to initialize or how to declare our mapping. Once again, you use the mapping keyword, right? Mapping. And of course, we have the key type. And then we have the value type, right? Then we have the name in this case. So let's do address. And now let's do value type of UINT, right? And let's set this to balances. Let's scroll up. Do we have any balances? Okay, awesome. So we have balances. Now let's write a function deposits, right? Let's set this to public. And we say balances. Now to access our value, in this case, we need to pass in the key. Now let's pass in an address in our function. Let's say address, and let's pass in a value joint value, right? And so I'm going to pass in an address over here and say that the value equals value, right? So this is how we sort of like deposits in this case. And so when you try to deploy to the local Remix VM, right, and you want to deposit, let's say you call this function, right, and you say the value is 10. When you call transact, you expect that the value is set. But now we can't see this because our balances is not set to public. So we have to do that, right? So this is why you have to set the visibility of whatever value or whatever data that you're working with. So let's quickly redeploy to the local instance of Remix VM. And when we click on this guy or copy and provide, let's say 1000. So we expect the balance to be 1000 when we are trying to check the balance. I mentioned that for every data type or variable for every variable that is declared to be public, there is a getter function that is automatically declared for that variable. Now, in this case, as you can see, our balances automatically brought out a getter function, right? Because it was declared public. So let's call balances. Now we have 1000. right? So this is pretty much the concept of, variables, especially in like smart contracts, Solidity, and whatnot. And so far we've been able to talk about value types, reference types, right? Pretty much. I think for today, that'll be the end of the class for today, lesson today. So our exercise will be to deploy. So I'll be providing us with like a registered or solo contract. The first thing we want to do is to, deploy the contracts on Kairos testnet using whatever platform. You use Remix. You can either use Remix deploy and run transaction tab, or you use Kaia plugin, right? Using Kaia wallet, right? Then what you want to do is you want to set the class. So you want to call the set class function, right? And you want to provide your name. So what that means is you provide your name to the set class. Then you're going to also provide how many students were on the call. And so I think we had over like 25 students in the beginning, right? So you're going to provide that here and the year, which is 2025. Now, the first thing you want to do is I added a bit of like events to the smart contract. So events are a way to like emit informations on the blockchain, to log information on the blockchain. This is usually useful for like front-end use cases, or when you're trying to like monitor stuffs on the blockchain, especially from your smart contract, right? And so what you want to do is to share screenshots of your emitted event logs. How do you want to do that? Locate your transaction, your deployment transaction, or your transaction hash when you call the set class function on the Kairos testnet explorer, and then you navigate to the events logs. Then take a clear screenshot showing all the events data, topics, and data field. Now, the first thing you want to do is to decode. Now, this is the first screenshot you take, the screenshot of all the events data, and also the topics and the data field. Now, the second part is to convert topic 1 to decimal using any online X to decimal converter, and topic 2 to decimal using any online X to decimal converter. Now, the third part is to decode the data field to reveal the string using any online X to string converter or AI. So you can use ChatGPT or Cloud, right? Pretty much. Then what you want to do is to share the screenshots of the decoded value, and you submit all 3 screenshots as your completed task. So that will mean that you submit screenshots of your topics and data field first. Then you also share screenshot of your topics converted to X to decimal, and also the second part of take screenshots showing the conversion of X values to their decimal equivalents, and also take a screenshot showing the decoded string from the data field. So those are like the 3 screenshots that you'd, show. So before the end of today, I'm going to provide the form for us to like submit our task. So it's basically just deploying your contract. I'm going to provide us with the contract registered or sold, and you call the set class function where you have to insert your name, the number of students available on the call, and the year, and then share screenshots of the event log in your Kaia scan, and pretty much it converts the X data to decimal using any converter or any AI tool, and then take screenshot of that also and submit in the Google form, which I'll provide later on after this class. I think that'll be all for today, right? Thank you very much, guys, for sticking through to the end. I hope you guys do, enjoy the class and got 1 or 2 from like the Solidity Fundamentals. Okay. Thank you very much. Thank you very much. Awesome, awesome. I Sean, I think we have like quite a number of like requests in the chats as regards joining the Discord. All right, guys, thank you very much. Sean, do you have anything to add? Right?
No, I don't. I'm just for those of you who are having issues with Discord, um, please do fill out the form that I sent previously. Yeah, other than that, I don't really have anything else. The reason that they're giving why your account was banned is because it joined from suspicious reasons, which is very confusing to me. So for those of you who have issues with Discord, please just send in your Discord ID so that I can unban you. And yeah, basically that's it. Yeah. And then I guess the next session will be held tomorrow at the same time at 2 p.m. West African time, 9 o'clock Singapore. So
Okay.
we'll see you guys tomorrow for part two of this exercise. I think it's fundamentals two, right? Solidity fundamentals two. So it's the more advanced class. So I'm hoping everyone can complete this and then complete this exercise. We will be checking. So, yeah, the links should already have been sent to your emails, registered emails. So just keep an eye out. Yes, we will be uploading the slides after this call to the Discord. So do keep in mind that, yes, as well as the recording. So, yep. So you can go and review everything and stuff like that. Yeah. So I do appreciate everyone. And for those of you who have friends who are also part of this bootcamp, please do remind them that there's a 90% attendance rate in order to participate in the hackathon. So far, that means you can technically only miss about 2 sessions. So, yeah, other than that, I have nothing else. Ayo?
Yeah, for sure. I think that'll be all from my end also. Yeah.
Okay, otherwise, take care, everyone. I will see you all tomorrow. All right?
Yeah.
Bye.
Bye, guys.